Ready. Okay, so today, Ingalls, we are going to use a different format when I record, which is again not it's just using my Google like a Zoom meeting rather than my camera, because I want you to have open Desmos, our graphing calculator. And so Desmos again will you when you launch it, it'll look a little bit like this where we can type in functions. And so just have that one ready because we are going to be using that in just a second. So with that, we're going to talk today about dividing polynomials, and we're going to use the remainder and factor theorems. Oh, oh, it is not showing. Oh, look at that. Hold on. Thank you so much, Kirsten. Sorry, I was talking and Kirsten wasn't seeing. So, because I didn't have it set up. So let's go ahead and get started with just dividing polynomials. Now, before I do, remember on 3-2, and as I talked to Kirsten just a second, the zeros that we talked about last on 3.2, in terms of the graph, when I graph that same function, what's going to happen is this place it's going to cross the x-axis. And so there's a lot of similarities that we're going to go ahead and investigate, or we're going to really look into, and it kind of helps you when when we're starting to graph our functions. Remember, some of the rules I don't want you to forget about are end behaviors. So remember odd functions will always have end behaviors if the leading coefficient is positive, going up and going down. And that's going to be, let me go, leading coefficient is going to be positive. And that means, and then you have an odd degree. Remember also if our leading coefficient is going to be negative, so leading coefficient is going to equal a negative, and it's odd, then it's going to look the opposite. So in other words, this is going to go up, this is going to go down. And again, all of this stuff in between, I'm just going to put some dots in here because they're all going to be connected. We just don't right now, just the end behavior, this is going to tell you what happens on every end behavior. When I have an even function, so let me go ahead and put a line here. If this one is going to be positive, then my end behavior is always going to go up on both sides. And again, what happens in between is what we're going to kind of continue talking about. But if it's going to be then the leading coefficient is going to be negative, then and my degree is going to be even, then what happens is that my end behavior is going to be going down both ways. And again, lots of stuff going on between depending on how complex my function is. So with that, when we do long division, we're dividing long division for polynomials is similar to what we do when we divide other numbers. For instance, I always take up and I go back to sixth grade. You guys want to go back to sixth grade for a second? And let's say that I have 5 and I have 132 and I'm dividing it by 5. Okay, so the process when you do this polynomial is has a lot of the same features. So when I did this first one, I said, well, what do I have to multiply 5 by so that it's to go into 13? So in other words, 5 times what is close to 13? Everyone says 2, and we put the 10 here. But remember, we subtract this out. So 13 minus 10 is going to be 3. The subtracting is going to be a key part for their polynomials. Just in a second, I'll show you a trick. And then the next step, we would drop the 2 down, correct? So we drop the 2 down, and I say, well, 5 goes into 32. How many times? 6. Yep. So 6. 6 times 5 times 6 is 30. And then I'm a remainder of 2. Now, when you first started off doing long division, you started to put an R, right? And you had R equals 2. But then you guys got older and they changed that. What did they change it to? Yep, you could go with decimal where we could add a decimal. Polynomials, you can't do that. But how do I write this as a fraction? 2 over 5, right? So our remainder, which was what we had is 2, divided by what we're dividing it by, which is going to be 5. Okay, so in other words, when I do a long division problem, I'm still going to do the same thing. Now, a couple of things you need to remember is I need to have every one of my, so like I had my place value here, I want to make sure that I have every term in descending order represented. So if by chance I didn't have an X term, I've got to make sure I have a place for it. So I put a 0. But in this case, I'm just going to go ahead and write 6x to the third plus 17x squared plus 27x plus 20. Okay. So again, writing them as a standard, putting them in descending order, and then I'm going to divide all of that by 3x plus 4. Now I'm going to tell you for this long division works for anything. So I'm now, if I ask you, like, what is 3x plus 4? How does it graph? By itself, just 3x plus 4. That would be a linear equation, right? With slope of 3 and intercept of 4. And so long division, you can divide this. This could be a quadratic. This could be a number that has a higher power. But our synthetic division, which we're going to cover in just a second, has to be a linear equation. We'll go ahead and discuss that before a little bit when we get to that. But the first thing I do is I say, well, what if I have 3x? What I want to do, remember on the first one we had we're dividing by 132. We said, well, 5 times 2 has to be 10, and that's what we end up doing. I want to ask myself, what do I mean to multiply 3x by so I get 6x to the third? Well, 3 times 2 is going to be 6, so I'm going to put a 2 up here. I have an x, but I need an x to the third, so that means the top number is going to be x squared. So I'm going to have 3x times 2x squared is going to give me 6x to the third. And that's kind of what I want. Pull it up there so you can see it a little better. And so then I'm going to multiply it through, just like I did before. So I have 2x squared, so I've got 6x to the third, and then I have 2x times 4 squared times 4, which would be 8x squared. Now, here's the trick. Remember, we subtracted before, correct? You're subtracting this whole binomial. And so a trick I've always used is when I look back on homework, it's hard to see, but when I draw the line, I change the sign. And what I do is I distribute that negative in so I don't forget, because a lot of times I get the first part. That's not a problem because I know I'm wanting to cancel this out. But so many times we don't get this one is subtracting because we just add them together. So make sure you subtract here, and then or add the opposite. So in this case, I'm going to go 17 minus 8, and 17 minus 8 would be 9, and it's x squared because we're dealing with x squared. And then I'm going to go plus 27x. Just like we did the 2, we drop it down. We're going to drop down the 27x. Now I'm going to ask myself, what do I multiply 3x by to get 9x squared? So in this case, I'm going to have 3 times 3 is 9. I have x times x would be x squared, so I'm going to put a 3x at the top. Then I'm going to multiply it through. So I end up with 9x squared. I'm going to go plus 12x. When I draw the line, I'm going to just change the sign so that I can just add, and it reminds me that I'm subtracting. So 27 minus 12 would give me then 15x. And then I'm going to drop down the 20, just like I did before. I have a 20. And then 3x times what would give me 15x? I already have the x, so I just have to constant. So I'm going to have 3 times 5 is going to be 15. And I already have the x, so 15x. Then I have 5 times 4, which is going to be 20. And in this case, I had a remainder of 0. So in other words, that is going to be a factor of the whole polynomial. Okay, so remember, when it becomes you have a remainder of 0, then you know that is actually, like, if I were to factor that, that's what this would look like. And so also, same thing goes too, that if I take 2x squared plus 3x plus 5 times x, 3x plus 4, I know that I would get my original back before, the same problem I had. Okay, so it works a lot the same way as what you learned with numbers. Now, synthetic division, here's the deal. You have to have to divide a polynomial by x minus c. In other words, what happens is that you have to write it in this form. So even though that we could have used synthetic division on the problem before, because we had a degree problem and x was to the first power, what we'd have to use then is the minus 4/3. But your problems that you're going to have are going to be a little different in the fact that I'm going to give you x minus a constant. Now, they could be plus a constant, but when we divide it with synthetic division, synthetic division just takes our long division and simplifies it. Okay, if you notice when we did this problem before, man, we had to write down the leading coefficients quite a bit at times. So it just makes it really concise and super easy. So let me jump down. We're going to do the problem. Now let me, and we'll talk about the process. If you need to refer back to the process, it's listed here. So I'm going to start off. I'm dividing it by x minus 2. And remember, I'm dividing, that is x minus c. And that means my function with that means 2 then is going to have to go outside my synthetic box. And I write it this way. There's a little jillion of people do it different ways, but I usually have always done it this way. And that's the way the book does it too. Then what I want to do is I want to write all of my leading coefficients, okay, in descending order. But remember, if I'm missing anything, I have to represent it with a 0. So I'm going to start off with 5x to the third. I'm just going to write the 5. Then I'm going to write the negative 6, and then I'm going to go plus 3, and then plus 11. Okay, and again, you don't have to have the plus, but sometimes for me, sometimes it helps me remember to make sure I do that. And I do go x to the third, x squared, x, and then constant. So in other words, I know I represented every one of my terms. Then when I start off, I draw the line. You begin by just dropping down the 5. So I start off, I'm going to start with the 5 here. And then I'm going to multiply 5 times 2. And 5 times 2 is going to be 10. And then you're going to put it in your next slot. So 5 times 2 is going to be 10. And then you put it right here. You will actually add now on these. So I'm going to put a little plus here. So I have a negative 6 plus 10, and that's going to give me 4. And then I'm going to multiply 4 times 2. And 4 times 2 is 8. And so I'm going to put 8 here. And again, I'm going to go ahead and remember I'm adding. So then I'm going to add 3 plus 11, 3 plus 8 is going to be 11. And then the last step, I have 2 times 11 is going to be 22. And then in this case, then I'm going to have then plus I have 33 as my end. So when I do this, I have a reduced polynomial that looks like if I start with x to the third, then this is going to be my x squared term. So I'm going to go 5x squared plus 4x plus 11 plus my remainder. And my remainder is 33. But remember, we're going to divide it by the x minus c. So it's going to be divided by x minus 2. Now, just to show you, if I take the long division of the same problem, so I have x minus 2, practice long division one more time. 5x to the third minus 6x squared plus 3x plus 11. Then I should get the same answer back. So in other words, what do I multiply x by to get 5x to the third? Remember, that's going to be 5x squared. And then I'm going to end up with 5x to the third. I'm going to go 5 times 2, which is going to be then a negative 10x squared. And notice when I draw the line and I change the sign, I'm adding 10. And that's what I did before on my synthetic division. So negative 6 plus 10 then gives me the 4x squared plus 3x. And so then I say, well, what do I have to do? What do I multiply x by to get 4x squared? And that's going to be the 4x. And so I go 4x squared minus 8x. We're going to draw the line and change the sign. And so I drop down 11, and notice, same thing. And then I have then 11x plus 11. And the last step, I'm going to have to multiply. I'm going to go plus 11. So then I'll have 11x minus 22, but I draw the line, I change the sign, and I have 33. So I get the same exact thing when I do long division that I do synthetic division. It just is nice because it just is a little simpler and it doesn't take quite as much room. But then I finish out by taking my remainder divided by what I'm dividing it by, which is x minus 2. Kind of makes sense? Pretty cool, huh? Now, here's why I've got Desmos. The remainder theorem, The remainder states that the polynomial that is divided by x minus c, okay, and again, you have to have it in the same form, then the remainder of f is f of c. In other words, whatever I had here when I had this before, I had a remainder of 33. So if I were to plug in, I'm just going to quickly do my Desmos. I have 5x to the third, and then I'm going to go minus 6x squared plus 3x plus 11. Okay, that was my function that I had earlier. And I wanted to know what happens when x is equal to 2. So if I were to scroll down here, when x is equal to 2, I need to have the point 33. So if I keep going up here like this, I'm going to get really close. X is equal to 2. Where am I going? I gotta go a little higher there. 2. There we go, 2. There we go. So 2, if I can finally get it to there, it's not going to like it really well, but notice that it is just right at 33. And so that's telling me that the same answer, so whatever I get as a remainder, also correlates to the point of f of that number. So in this case, I'm going to look for f of negative 2. Now, in this case, that means that I have the point, my x minus c is actually x minus a minus 2, which is also x plus 2. So if I actually, when we did the problem before, it's going to always look inside my box like the opposite. But when you have f of negative 2, you just put negative 2 here. So in this case, I'm going to start off negative 2. I want to make sure that I have descending powers. So I have x to the third squared to the first and then constant. So I just write the leading coefficient. So I'm going to go 4, 5, negative 6, negative 4. Then all I'm going to do is I'm going to drop down the 4. So I have 4 here. And then 4 times a negative 2 would be negative 8. Remember, add. Don't forget you're adding this. It's different than dividing it. So in this case, 5 plus a negative 8 would be a negative 3. But now I have a negative 3 times a negative 2, and that's going to be 6. And so when I add together, I'm going to get a 0. And then I'm going to have 2 times 0, which is 0. And so my answer then is going to be negative 4. So going over here to my next function, let me go ahead and write, I have 4x to, I'm going to go ahead. It does reduce, you're right, to my reduced polynomial would be 4x squared minus 3x. And then, but I have plus or minus a 4 over x minus 2, x plus 2 is how I would write that as a reduced polynomial. But let's just check to see if I get 4. So I'm going to put in my original function. So 4x to the third as I write 2. Okay, let me try again. Then I'm going to go plus 5x squared minus 6x minus 4. Okay, and so I'm going to get rid of my red line, but I want to know what happens when x is equal to 2. So when x is equal to 2, let me span this out so I can see it. Okay. Or sorry, when x is equal to negative 2. So x is equal to negative 2, then I have the point, then negative 4. Pretty cool, huh? I think that's also cool. Well, there you go. Quick look. Okay, let's go ahead and move on. So when I think about that, remember, this is a function too, where these are going to be my zeros. So if I were to plug in any number that is crossing my x-axis, then that's also going to be the 0. So when I look at the next one, if I'm going to go ahead and plug it in. So I have 3x to the third plus 7x squared minus 22x and then minus 8. Kirsten's my facts checker. So they're asking, is 1/3 going to be a 0? Now, from my graph, it definitely appears that. And so does it appears also that 2 does. Notice that if I zoom out, that also shows you my end behavior. I have a other 0 at negative 4. So what happens is I can plug those numbers in to using my synthetic division and to verify that they're actually going to be a zero because they should get, my remainder should be zero. So let's start with -1/3. In this case, I'm going to have 3. I go 3, 2, 1, 0. So I have 3, 7, -22, -8. Start off by dropping my 3 down, which is 3. So 3 times 1/3 is actually just going to be -1, right? So I'd have -3/3. And then I have 7 minus 1. That's going to be 6. 6 times 1/3 should be a -2. And so then I'm going to have drop down a -24. And then when I take a -24 times a -1/3, that's just going to be a +8, and I get 0. Because that's a 0, that also shows me I have a 0. So there is no remainder, right? It would be what it says. And also it correlates with the fact that in this case at 1/3 right here, that I had the value of 0 from my graph. I also know from when I look at Desmos, I have a 0 at -4, and I also have one at 2. And so I could do my reduced polynomial here, which is now, remember, it's 3. If I start off x to the third, it changes to 1 less. So it's 3x squared plus 6x minus 24. Now, notice that I can use those same numbers, which I'm going to. I could also factor a 3 out to make it a little easier, but I just went for my graph and I said 2 is also a root. So if I put 2 into here under my reduced polynomial, which is 3, 6, and -24, I better get 0 at the end here. This needs to be 0 again. Okay, so let's just check it. So I'm going to drop my 3 down. I'm going to put a 3 here. I'm going to go 3 times 2, which is going to be 6. 6 plus 6 is going to be 12. 12 times 2 is going to be 24. And 24 minus 24 is 0. So again, that shows me that I have multiple roots. I could do the same thing then with my reduced polynomial and solve for -4. Pretty cool, huh? Okay, so synthetic division, I like. I have also had great math students that love long division. Okay, I like synthetic division, but remember, in order for you to have synthetic division, it has to be like a x minus c. In other words, you have to have, it could not, if you ever have an x squared minus 3, you cannot use synthetic division for that because it's a quadratic. But if you have a linear, a degree of 1, it's awesome. So, all right. I'll let you get busy on your homework. Let's go ahead and stop.